Hey, welcome back to maths. Today we're looking at limits and continuity. So we've had the chat about limits before, so we're just going to, I guess, touch over this again. Again, if you see this particular notation here, what it is saying is the limit of f of x as x approaches a is equal to p. Another way of saying it, as I say here, is as x approaches a, f of x approaches p. Yep. So it says here, this means that we could make the value of f of x as close as we like to p, provided we choose x values that are close enough to a. Cool. So example 28 here, it says find the limit as x approaches 2 for 3x squared. So what we're going to do is we're going to substitute in 2 where this x is, and which is basically saying as x gets closer and closer to 2, we're going to find out what the value of this is equal to. By substituting 2 in and evaluating, we can see that it gets closer and closer to 12. There's an extra little step that needs to take place if you have something as follows. So with example 29, we've got a function except for values of x, x doesn't equal 2. So if we think about this particular function, you can see there is a gap at x equals 2 because it's not included. So if you were just to evaluate the limit of this function as it stands, if you substituted 2 in there on the bottom line, because you're dividing by 2 take away 2, which is 0, it's going to cause an error. So the way in which we handle this is we're going to factorize and cancel things out where possible. So the good news is the top line of this function here does factorize to 2x take away 1, x take away 2. Then what can happen is this x take away 2 cancels out with the x take away 2 on the top line. That fits into itself once, and that fits into itself once, which leaves you with 2x take away 1. Now, when you've done that, you can then evaluate the limit by substituting 2 into it. 2 times 2 is 4. 4 take away 1 is the 3. Yep. So you can get that limit there with that one. Some of the other things that you need to know with regards to the algebra of limits are the following rules. If you are dealing with the sum, that is, you're trying to find the limit as x approaches a value for different functions added together, then it's the same as working out the limit of the first function plus the limit of the next function. With multiple, if you have to find the limit of k times a function, you can pull that k value out the front and then just evaluate the limit of the function. If you are dealing with a product, that is, if you're finding a limit of a function multiplied by another function, it's the same as finding the limit of the first function, f of x in this case, multiplied by the limit of the second function, g of x. Quotient is the same thing. If you have to find out the limit of a function divided by another function, you find out the limit of the first function, which is f of x in this case, divided by the limit of the second function. Yep. So here are some examples dealing with that. It says find the limit as h approaches 0 for the following. This is a sum case. We've got a function plus another function. So what we really need to do with this one is find the limit as h approaches 0 of 3h, and then add the limit as h approaches 0 of 4. So breaking it up into those separate things, we can work out, if we substitute in 0 into here, we can work out the limit of this part here. 3 times 0 is 0. The limit as h approaches 0 for the 4, it's just going to be 4. Adding those together, 0 plus 4 is 4. Next one here, we've got two functions multiplied by each other. This is a product scenario. So you've got the 4x multiplied by x plus 2. So what we're going to do is find out the limit as x approaches 2 of 4x, and then we're going to multiply that by the limit as x approaches 2 of x plus 2. So doing that, limit as x approaches 2 of 4x, substituting the 2 in there, 4 times 2 is 8. And that's going to get multiplied by the limit as x approaches 2 for this one. Substituting in 2, it's going to be 2 plus 2, which is 4. We can multiply those together and we get the 32 in this case. No surprises here. With this one, it's the quotient type. We'll need to work out the limit as x approaches 3 for the top line and divide it by the limit as x approaches 3 for the bottom line, which we can do. Alrighty, next thing we need to... Oh, there's some more. Sorry, I was jumping ahead here. Again, when you have some scenarios like these here, if you are evaluating the limit as x approaches a value and the bottom line of the fraction becomes 0, you have to be able to handle it some other way. So more often than not, it's about factorizing things and then simplifying things down. So here we've got x squared take away 3x. On the top line, x is a common factor of both of those, so it can be pulled out the front, and you end up with x brackets x take away 3. Then you can do some simplification. You can simplify x takes away 3 fits into itself once, and x take away 3, oops, that's meant to be a 1, fits into itself once, and x take away 3 fits into itself once on the top line. So that just leaves you with x. So we're finding the limit as x approaches 3 of x. Substituting that in there, it's going to be 3. This one here, factorizing the top line, conveniently, it does come out to x take away 2, x plus 1, which again means that things can be cancelled out. If we cancel out the x take away 2 here and here, you end up with just x plus 1. Evaluating that limit as x approaches 2 of x plus 1, 2 gets substituted in, 2 plus 1 is 3. This one here, there's simplification that needs to, or factorization that needs to take place on the top and bottom line. Top line factorizes to x take away 2, x take away 5. Bottom line is a difference of perfect squares. X squared take away 5 squared factorizes to x plus 5, x take away 5. Again, you've got an x take away 5 on the top line, x take away 5 on the bottom line. They cancel each other out, and you're left with x take away 2 on the top line, x plus 5 on the bottom line. Again, from the quotient rule that we spoke about just prior, what you can do is you need to evaluate the limit as x approaches 3 for the top line, and then divide it by the limit as x approaches 3 for this bottom line. We can do that, and you get 1/8. Alright, the next part we're looking at is what's known as left and right hand limits. Now you do need to know the difference between your left and right hands for this, so hopefully you've been able to deal with that before. So when we're talking about the left and right hand limits, what you're going to see is whether a limit exists if you're coming in from the left hand side of the function or whether it's coming in from the right hand side of the function. Now, the way in which they describe these, if you're coming in from the right hand side, you're going to have the notation as follows. It's going to be the limit as x approaches positive a. So it's an a with a little plus. So the number with the plus means coming in from the right hand side. On the other hand, if you're going for a left hand limit, you're coming in from the left hand side, you're going to have this notation, as limit as x approaches the value with a little negative there. Obviously, I'm mirrored here in my left and right. I do know the difference between my left and right. Okay, trust me. Yep. Now, cool. So you got your left and your right hand limits. Perfect. One's coming in from the right hand side, one's coming in from the left hand side. Now this comes into play when we talk about what are called piecewise defined functions, or as I like to refer to them, hybrid functions. So you can see here, it says the following is an example of a piecewise or hybrid function where the limit does not exist for a particular value. So you can see between 0 and 1, you've got x cubed. Notice the open circle here. At x equals 1, it's 5. So you can see the closed circle there. and between 1 and 2, it's 6, so straight line there. Notice again the open circle for this value here, and the closed circle where it's included. Yep. So it's less than or equal to 2, so it can be included. So what they're saying here is it's clear from the graph of f that the limit as x approaches 1 for f of x does not exist. However, if x is approached or allowed to approach from the left hand side, so here I'm on the left, moving this way, coming in from the left. As we come in from the left, then you notice that f of x does approach 1. Yep. On the other hand, if you come in from the right hand side, we're coming in this way, as we get closer and closer to 1 from the right hand side, then the limit, it approaches 6. Yep. So notice that they are different depending on whether we come in from the left hand side or the right hand side. Same sort of thing can happen with other functions, and looking at a rectangular hyperbola. If we look at the left hand limit, so as we come in from the left hand side, we get closer and closer to 0. This gets closer and closer to negative infinity. However, if we come in from the right hand side and we go closer and closer to 0, it looks like it's approaching positive infinity. Yep. So you can see that they are different as we move in from the left hand side to the right hand side. So that leads us to the next part, which is what's called continuity at a particular point. So it says here, and essentially what we're looking for here is if the left-hand limit is the same as the right-hand limit, then they are continuous at that particular point. Yep. And this is really saying if a function can be drawn through the points without a break, then it's said to be continuous. If there is a break at that particular point, then it's said to be it's discontinuous. Yep. There are some things that we need to be aware of. It says a function f is continuous at a point x equals a if the following conditions are met. First dot point is that f of x is defined at x equals a, and also that the limit as x approaches a of f of x is equal to f of a. Cool. So what they can ask you to do is actually say whether something is continuous or discontinuous. So it says here, state the values for x which the functions shown below have a discontinuity. Here, as we move along, and the way I think of it is if you can draw these functions without imagine you got a pen in your hand. If you can draw these without taking your pen off the page, then it's continuous. If you can't draw these without taking your pen off the page, then it's discontinuous. So look, as I'm drawing along here, I'm drawing. Even for me to go and put this dot here, I have to take my pen off the page. Yep. Then come back down and continue here. So it's going to be discontinuous at that particular point. So they're saying here at x equals 1, you can see that it's going to be discontinuous. Likewise here, if I'm going to draw this one, I'm drawing up until this particular point at -1, then the pen has to come off the page to continue drawing this part. So it's discontinuous at this point. Continuing drawing here at 1, I have to take the pen off the page, it's discontinuous there as well. As we go here, drawing, have to take the pen off the page, it's discontinuous at these points. And also, as we're saying, it's discontinuous because as we move in from the left-hand side, the left-hand limit is going to be different than the right-hand limit. So what they're saying here with this, at x equals 1, if we come in from the left-hand side, so the limit as x approaches 1 from the left-hand side, you notice it gets it approaches 1 at that particular point from the left-hand side. If we come in from the right-hand side, we take the right-hand limit as we approach 1, it comes out to being 2. And because the left-hand limit is not equal to the right-hand limit, it's discontinuous at that particular point. Okay. Last thing I want to talk about is you can be given hybrid or piecewise functions, and they're asking for us to find out whether there is a discontinuity between each of these things. And so it's a matter of thinking about what is happening around these positions here. So if we've got 2x for values of x that are greater than or equal to 0, let's find out what's happening at 0. So if you substitute in 0 into here, 2 times 0 is 0. Yep. So as we come in from that side, it's approaching, or it's 0. Yep. On the other hand, as we substitute in 0 here at this particular point, negative 2 times 0 is 0. 0 plus 1 is 1. From that side, it's going to be, its limit is 1. So obviously at one particular point it's 0, on the other side it's 1. There's a gap there. It's not the same on either side. Yep, it's discontinuous at that particular point at 0. Yep, you would have to take your pen off the page to draw that. So you would say there is going to be a discontinuity at 0, or x equals 0. And that can be done for each of these other ones as well. Alrighty, thank you very much for listening up. I hope you enjoy this activity. Bye for now.